So hi guys, today we are came with another part 2 video of Apache Spark, where this is the second part and there is one more final part is there, okay, which is very short video which consists of only Spark optimization techniques, okay. So let us concentrate on today's video. So in previous video, we have discussed about what is big data and what is Apache Spark, what is the role of Databricks and why we are using it, what are driver nodes, worker nodes, what is Spark architecture, etc., etc., all these things. What is DAG also we have seen in our previous video. So in today's video, we are going to deep dive into the all the topics that we are going to that come across this Apache Spark. Okay, so please be patient, and as well as the people who are new to this particular field, or the people who are new to this big data Apache Spark and all, they might confuse a bit. So that's why kindly please take notes. Okay, take notes, which is very important. Write each and every part and try to analyze it again and again so that you could able to remember it. If not, everything will get vanished as soon as possible. Okay, so in today's part 2, what are the concepts that we are going to discuss is we are going to discuss in depth about the DAG, how DAG is been created, and second thing, how what we call it as partitions are being created, what is repartitioning, okay, what is repartition, partitioning, TION, okay, repartitioning, and what are what we call it as hash aggregations, hash maps, and as well as hash aggregations, and how are what are the transformations that we are having. Transformations means do not think about PySpark transformations. These are the transformations that we are going to discuss on the Apache Spark perspective, like why transformations as well as narrow transformations. Okay, so once the transformations part is been completed, we are going to discuss about something called as shuffling, and we are going to discuss about something called as what are joins, and how many joins are there for this, and much more concepts are there. These are the just subtitles that I have given, but there is lot to discuss on this concept, and you need to understand a lot. Okay, so till our previous video, we have discussed about, I think I have left in my previous video till DAG, I think so, but I haven't discussed about the DAG completely. Okay, but in today's one, we are going to discuss about something called a Spark plan. What is a Spark plan? See, Spark plan means nothing. How the code will execute from end to end. Okay. For suppose if I am the user who is writing my code and running my cells and all, what Spark will do initially, Spark will initially convert that plan into a logical plan. Logical plan means simply see nothing it will do. It will just whatever the transformations you are doing, it keeps on adding to some logical plan, but it's not optimized. Okay, it not optimized. It will add only your code, that whatever the code that you have written, that code only it will add into logical plan. So Spark will not perform any nothing it will do. Okay, once the plan went to logical plan, what Spark will do, it will do optimization of it by using something called as catalyst optimizer. What this catalyst optimizer will do means, whatever the plan that you're writing, whatever the code that you're writing, for suppose if some cells are not needed, it will remove. For suppose if you are performing unnecessary 4 to 5 transformations, but those transformations can end up within 2 only. Okay, but you have written 5 transformations, what it will do, it will simply remove those transformations and all, and it will do match out of it. So like that it will do all the optimizations, and if any sequence problems are also there, the sequence also it will adjust the sequence, and it will be a logical plan. So then when this plan got optimized by catalyst optimizer, Spark will convert that logical plan into physical plan. Physical plan means, okay, this is a proper plan and this is in an optimized state, and we can use this plan. It just like as a while before construction of any building, we'll prepare one plan like that, like normal plan, chart maps and all like that. Okay, so whenever till Spark, everyone knows we discussed about lazy evolution in our previous session and all. What Spark performs whenever you give action commands, then only it will execute your entire code. Till then, it will keep on performing the lazy evolution. It keeps on adding to logical plan, and logical plan will optimized by Spark by using Catalyst optimizer, and that will be converted into physical plan. This is what happens. But when you give action commands like what, like count, show, display, read, if you write any data or if you read any data from any CSV, these are action commands. So when you give this action commands, what Spark will do, first of all, Spark schedules a job out of it. And we'll discuss about what are jobs and all in detail. Okay. Once the job gets scheduled, what Spark will do means immediately there is something called as a DAG scheduler. S- What DAG? What is a DAG? DAG means directed acyclic graph. Okay. It will tell the RDDs. It will what DAG is just like as a giving a plan to the executors what to do. So DAG will be prepared by the driver node. So whenever you click on action commands, what driver node will do? Driver node immediately prepares a DAG. It immediately creates one job, and for that job it prepares a DAG. Means it's a DAG, means it will give, okay, how many executors are there, and how many executors or how many workers are there for us, and which worker what task they need to perform, and what are the how many partitions are there, and how many records we need to give, and how many partitions we need to make, and all these things will be there in the DAG, which will be prepared by the driver node, and this will be given to the uh, executors. In between there is something will happen called as RDDs. We have already discussed about it. Okay, now once the DAG is been prepared, we'll discuss about the stages. Once DAG is been prepared, just listen what I'm saying, and later on you will understand what I'm. Now it will prepare the stages. Okay, stages. Make this point note that stages will be defined by the number of shuffle happened. Okay, once stages are been done, within the stages there are number of tasks will be there. Okay, each task will given to so means one task is been given to one partition to one particular job. Okay, one partition, one task will be given to one particular core. Okay, one core is equal to one partition that we have divided. Finally, this will be executed by the executors. This is what the Spark plan. I'm repeating, initially whatever the code that we are having, that code will be just added into logical plan which is not optimized, and that will be optimized by the catalyst optimizer, and that catalyst optimizer will be converted, sorry, not logical plan will be optimized by using catalyst optimizer, and once it is been optimized, that will be converted into physical plan, and when you hit action commands, till then it keeps on it keeps on what we call as adding out all the transformations like that only in a bucket kind of thing. And once it gets done, Spark creates job, and once job is been created, there is something called as DAG scheduler, which creates a DAG. And DAG scheduler, these all things will be done by the driver node. And once this has been done, whatever the stages that we are having, it creates stages, it creates tasks within the stages, and finally it executes our work. This is what completely about our these things and all. Okay, fine. Coming to the next one. Okay, what are transformations? So I'm keep on telling in this session now that whatever the transformations that we are performing, all the transformations will be added into the logical plan, then converted to physical plan and all. Now discuss about what are the transformations we are having in our Apache Spark. Okay, okay. Now what are the transformations we are having in Apache Spark? Okay, transformation means, see, every time when you perform some change in your data frame, that's a transformation. Okay, Simply, if you want a definition, a transformation is an operation, okay, that creates a new RDD. New RDD. RDD means resilient distributed data set, okay, or a data frame from the existing one, okay. You'll get to know what why it is creating new RDDs and all. You'll get to know, okay. Every time when you perform new transformation, for suppose initially I have performed something called as filter, okay. Oh, why? Oh, okay, let me take it somewhere. Okay, see, initially you prepared something called as df dot filter. You have done something called as df dot filter. You have filtered something called as dept underscore id is equal to 10, department id 10. You have filtered it up. Okay, for this filter, it creates one RTD plan. Okay, and after that, you have done something called as you have ran the entire code and you want to add one more thing. You have done something called as group by with respect to department ID and all. What this will do, it will create one more RDD. Instead of using the same RDD, it will create one more new RDD out of it, and it will use both the RDDs to display your data. Okay, I hope this is clear. Now you will get to know each and everything slowly. If you are feeling that I got missed somewhere, so you can rewatch this part again and again, no issue. Okay, now let me go with the things. Okay, sorry. Now, what are transformations? A transformation is an operation that creates a new RDD or a data frame from the existing one. Okay, existing one. Transformations are lazy. As I told, transformations are lazy, meaning they are not executed until you give any action button, so-called action button. Okay, now, how many types of transformations do I have? We have only two types of transformations. One is narrow transformations. Second one is this wide transformations. Okay. What are these narrow transformations and wide transformations? Okay. Let me explain you what are those things. See, boss, narrow transformations mean, see, I think everyone is aware of a bit about partitions and all. What are partitions and all? Partitions means dividing our data into small chunks, right? A narrow transformation is one where each output partition depends on only one input partition. Okay, let me explain you clearly what I mean. Okay, see, there is something called as sheet one. Okay, this is my initial data. Okay, let me rename this one called as initial data. Okay, I'm having, okay, I'm having two things: name, age, and salary. Okay, not name, not age, name, gender, and as well as salary. Okay, I'm having three things. Okay, right now let me add a table for that. Okay, within this I'm having a table. So let me or what we call it as create this one. Just a second. Okay, yeah. So see, this is what the data I'm having. Okay, consider I have saved this in a CSV file called as initial data. What I have done, I have used one data frame. Df is equal to spark dot read dot format, and what I have done, I have read this file. Okay, format is something called as CSV, and as well as dot load, I have given all info schemas and all, and I have given this initial data. Okay, initial data. The code is wrong. Okay, but to make you understand, I have wrote it like this. Okay, so within this particular data frame, this entire data is being stored. Okay, now let us discuss about what are narrow transformations and what are wide transformations. Okay, before that we'll discuss about what are partitions. Okay, partitions means, for suppose, how many records I'm having. Total I'm having 9 records I'm having. If I remove name and gender, Total I'm having 9 records. What I have done is, see, I'm having default partition size is 128 MB. Okay. If any file crosses till 128 MB, it will consider that file into one partition. If that file crosses 128 MB, that even one record also, that record will go to another partition. Okay. Consider this will be in KBs, not KBs, also in bytes. Okay. Now, if for suppose, if my particular whatever this file is there, consider my file size is something called as uh, 480. Okay, consider my file size is 480. How many partitions I could able to make? 480 MB. How many partitions I could able to make? Three partitions, hardly. 120, 120, four. Oh, let us take four partitions. Okay. Now, how I can do four partitions means, what Spark will do means, it will take these two people. Okay. It will take Rohit and whatever the Divya is there. Okay. P0 partition 1, first partition. Okay. P1 second partition, P1. Okay. P2, P2, P3, P3, and last partition is P4. Okay, or let us take Reshma into one partition only, no issue. Okay, what it will do means, see, it will split my data. How it will get split? Because with the help of RDD. What RDD will do? Resilient distributed data set. What this will do? It helps to split my data, or it helps to partition my data and distributes over the executors. What this will do now? See, it will split. Take another sheet, rename. This is P0 partition, first partition. Okay, or let us take partition dash 1. Okay, now let me add, oh sorry, partition this one. Okay, let me add it over here. So these two people will come in this partition. Okay, these two people will come in this partition. Okay, now what it will do again, same like how rename partition 2. Okay, it will take these two people. Okay, and it will add it over here. Okay, similarly it will take one more partition. Okay, it will take one more partition, rename. Okay, partition 3. Okay, partition 3, and it will take these two people, add it over here. Okay, now last three records will come and placed in the last partition, rename partition 4. Okay, that's it. Okay, let me zoom everything. Okay, and this one also let me zoom it. This one also let me zoom it. Okay, similarly, like how everyone will split the data like this. Okay, so this is name, uh, gender, and as well as salary. Control B. Now name, gender, and as well as salary. Okay, this part will be removed, no issue. Name, gender, salary. Sorry. Yeah, see guys, I have adjusted the data. Okay, This is my initial or what we call it as, this is my initial table, where my table is almost all 480 MB. So defaultly the partition size is 128 MB. What it had done as per the calculations, it had made converted into three partitions. It had made my data, split my data into three partitions. Splitting data into small chunks is called as a partition simply. So in partition 1, I'm having Rohit and Divya. In partition 2, I'm having this Shiva and Dina. Partition 3, this one. And you need to understand one thing, each partition is having 128 MB. Okay. So I have splitted my data into number of partitions. Now you just tell me that I have asked one question with you, like, boss, I want to know, uh, only the people who are male, whose gender is male. I want to know who's the people whose gender is male. So at the time, what I will do, I will write a df underscore 1 or df underscore what do you call it as a filter, because I need to apply the filter. What I'll do, df dot filter. Anyhow, I'll display this in what we call it as um, I'll show it in PySpark also, so you'll get more knowledge. But try to first grab the concept. Okay, df dot filter. What I need to filter? I need to filter the people. Okay, what gender equal to m. Okay, so this is what I want to grab. Whenever I have wrote this one, okay, you need to understand one thing. This df will create one rdd1. This df will have one rdd1. And when I have created df underscore filter, it will not what we got is go with rdd1. It will create one more rdd2 with the help of rdd1. Okay, for suppose if this rdd2 gets failed. Okay, for suppose if this rdd2 gets failed, nothing will happen. It will again read the rdd1 which was previously been executed, and again it can rebuild it. Again it will create the rdd2 with the help of DAG steps and all. That's it. Okay, that's why it is called as resilient. Means if it dies also, it will read its previous steps and all, and again it can recreate, no issue. Okay, now df underscore filter, df dot this one I have given. Okay, now this is what I can say. By looking at it only, I can say this is a narrow transformation. Narrow transformation. How Rohit, how you are telling by just by watching this a narrow transformation being? See, narrow transformation now, each and every partition is an individual partition. There is no data requirement is there from the previous other partitions and all. Okay, there is no data requirement is there in the other partitions and all. Example, see, if I have asked you, you will take the sheet one or the partition. What you will say? See, Rohit is there who is male from this. He will capture from P1. Okay, nothing. You need to go to P2. Okay, what you will say? Shiva is there. Shiva is there from the other what we call it as partition. Yeah, you will take this one. Okay, you will go to partition 2. Okay, Chandu is there. Chandu is there from the partition 3. Okay, and as well as Satya is there from the partition 3. That's it. You will make a note of it. And again, you will go to partition 4. And you will say Ravi is there, who is a male from the partition 4. Okay, here if you see, no person is dependent on another partition. Okay, means I need to what we call it as fetch the data from other partitions and all, and I need to go to other partitions and all, and I need to compare with the other partitions, then only I can able to take the decision. No, it will just each and every partition will take its own individual decision, and that will be just given to the executors. So that is what I have just mentioned over here. That see, narrow transformations is one where each output partition depends on one input partition only. Like see, one input partition when I'm getting, output also will be that partition only. It will not depend to another partitions and all. So partition 1 dependent on partition 1 only. It will get from partition 2, it will get it up to partition 2 only. It will not go to any partition 2 or anywhere. So there is no data movement or shuffle across the cluster. You will get to know what is a shuffling. Okay, now before going to that, let us just look at this particular example that I have created for narrow transformations. Okay, this is an example that for narrow transformations. Okay, see, there are four records are there: Rohit, Divya, Tushar, and Satya. Okay, so when I have what it will do, the RDD, it will split my data into small chunks. Those are partitions. So here what it had done, it had splitted my data into two partitions. See, I have, for your readability purpose only, I have splitted two records. Basically it will not go like that. 120 MB is a fixed one partition size. Okay, so there are ample of records you can able to read from that. Okay, but for your readability purpose I have given like that. Okay, where Tushar and Shiva is there, who is there under partition 2 of 3 and 4. Okay, now when you go to what it will do, so this is your executor. In our previous, if you have seen my previous video, one executor consists of worker node. Every executor has worker node which has 16 GB and 4 cores. As I have wrote, it has 16 GB and as well as a 4 cores. 4 cores means what? What cores will do? Cores will help to do the parallel processing. Means at a time, for suppose if you are having 4 cores, means at a time 4 partitions can run simultaneously. Okay. See, whatever your RDD is there, okay, it will give partitions. Okay, you are having two partitions. Each partition is having two records. Okay, and this is distributing your data to your particular executor or a worker node. Your worker node is having 16 GB and 4 cores. Okay, this is not standard. This is not standard at all. It keeps on changing. Okay, but whatever the worker node, single node I have created, that is 16 GB and 4 cores. As I have told, each partition will be handled by one core. So I'm having only two partitions. So these two partitions, the first partition will go to the partition first core, second partition will go to the second core. Okay. And one task and task, okay, we'll discuss about the task. And these two are idle. Okay. These two are idle. Okay. Now, let me tell you one more thing. Okay. For suppose you are having only two partitions. If you are having four partitions, like one, two, one more partition is third partition, fourth partition. Four cores will handle it. Okay, okay. What if you are having six partitions, but you are having only four cores? What it will do means the first four partitions will be handled by the first four cores, and whatever the fifth partition and sixth partition is there, that will be weighted in the queue. So once the first partition, second partition, and whatever the partition will, whatever the core completes one partition, then only the it will move from queue to that particular partition. It could be any partition. It's not like that. Okay, these are what narrow transformation. So these are individual transformations. Okay, one source you are getting input, and that input only going to one partition only directly to a executor. There is no shuffling happening in between. Okay, you will get to know what is shuffling after this. Yeah, just listen and go. Okay, now come boss, we are going to discuss about the wide transformations. See, narrow transformations are efficient. Okay, narrow transformations are efficient, not efficient. See, efficient means most of the times we use wide transformations both combined. But what is the main advantage of narrow transformations means it will not take that much disk space, or it will not take that much amount of network. Okay, where it costs more, the cluster cost is very more, because wide transformation performs something called as shuffling. What is shuffling? Let me tell you. So what is wide transformation? A wide transformation is one where each output partition depends on multiple input partitions. Okay, where each output partition, just watch this point very carefully. I'm going to discuss what I mean. Where each output partition depends upon multiple input partitions. Okay, this requires data shuffling across the cluster. Okay, what it meant is, see, yeah, what it meant is, for suppose this time I didn't ask you the same question that was there before, like Satya, Chindu, all. Okay, this time I have asked a question, okay, to you, that see, I want to know how many mails, I want to know the count of count of males. I want to know the count of males and females. Okay, females. And one more question I have asked you, that boss, I want to know that how many, what is a max salary in males and same like max salary in females. Then what you will do? Will you take your individual decisions with each partitions? No. What you will do, you need to compare with one partition to another partition to one more partition. So like that you need to shuffle the data from one partition to another partition. Okay, that shuffling the data is a very interesting concept. Okay, but you need to pay attention a lot to understand that. Okay, there are so many things happens in that, like hash aggregations and all, so many things. Okay, why to go that much depth? So let me explain you what it will do means. See, first of all, I have asked an initial question for you, like that, what, how many count of males and females? If I have asked you the question of what is count of males and females, see, the males are not only there in the partition one, the males are there in all the partitions, and same like how females are also there in all the partitions. What you need to do means, see, you, there will be, when you have created what we call it as white transformations, defaultly it will create 200 partitions for you, because there is a point of shuffling is there. The data will get shuffled within one partition to another partition. So defaultly when you are performing what we call it as white transformations, you will get 200 partitions, but this concept we'll discuss, no issue. But see how it will be, it will go. Okay, these are the partitions that were created by the RDDs, right? What RDDs will do, RDDs will take the sheets and all as an output partitions and all, input partitions, output partitions. I told now, whatever the output partitions are there, those many, the records will come from multiple input partitions. As I have told, what are white transformations? Okay, this is what, this is output partition. Okay, for what, this output partition is only for males. Okay, and there is one more output partition is being created, that is output, okay, part for females. Okay, one output partition, this one. So these are all partition 1, partition 2, partition 3, partition 4, these are all input partitions. Okay, what this will do means, in output partition, that this data will be taken, like see, Rohit is will be taken. Okay, it will get shuffled to this one, it will go over here. Okay, and it will compare with partition 2 also. Okay, and this data will be taken and this will be driven over here. Okay, delete, delete. Okay, let me go to, so it will go to the second partition. Okay, what it will do, it will take Shiva from there because he is also male. Okay, that he will go over here, and it will go to third partition. He will take Satya and Chandu from there. Okay, Satya and Chandu from there, and those two will go to the this one over here, and he will go to fourth partition where Ravi is only person who is there male, and he will go over here. He will go over here. Okay, now same like how it will do for the other partition also. Okay, for females, if you go to first partition, same Divya is there. Okay, Divya is there, she will get deployed over here. Okay, and in the second partition you can see Deena is there, she will get deployed over here. She will get deployed over here. In the third partition, no one is there. Okay, third partition only males are there. Fourth partition, Nageshwari and as well as Reshma is there. Okay, let me take their names, and as well as one more person is there, Reshma. Okay, let me take her name also, and let me put it aside like this. Okay, now what it will do, see, these two are the output partitions. Okay, these two are the output partitions. What I have told in this one, in this one, a Y transformation is one where each output partition depends upon multiple input partitions. So this requires shuffling across the cluster. So what it has done, shuffling has done na, from partition 1 I got data to mail, from partition 2 I got data to mail, from partition 3 I got data to mail, 4 also I got data to mail. Like that partition 1, 2, 3, 4, everywhere I got data over here. So whatever the output partitions are there, I'm getting input from the input, sorry, I'm getting from multiple input partitions. Okay, but now let me tell you with a proper example. I'm having one proper example. So this is also one good example, but I think it is all easy to understand only. I'm having two partitions. These two partitions, I'll get one data. I'm having another third partitions. It will create one more partition over there. So this is what super example where you can see what happens in between RDDs and all. Okay. Now if you see over here, I'm having Rohit, same data. See, same data. Rohit, Tushar, Divya, Ravi, Shiva, Deena, and Nageshwari. Rohit male, all males, females, all got shuffled. So what it will do initially for Rohit, Tushar, and Divya, for these three people, it creates one RTD, one partition. Why one partition? Because that file has been 128 MB. For Ravi, Shiva, Divya, Nageshwari, these four records it had created partition 2. When it is going to executors, when it is going to executors, as I have told, the default partition size is 128 MB. Let me scroll this up. Okay, like this. Yeah. Now, if you see this one, there is something happening over here called as a data shuffling. What is this shuffling? See, here I'm having two males. Here I'm having two males. In Divya, I'm having one female. Deena and Nageshwari also I'm having two females. What it will do, it will shuffle the data from, it will shuffle the data from one partition to another partition, like shuffling the cards and all. It will take males, all the males to one partition, and it will take all the females to another partition. This is what we call as shuffling the data or redistributing the data across the partitions. This is what actual definition of shuffling. Shuffling means redistributing the data across the partitions. Okay, this is my executor or a worker node. So I'm having two cores. One core will take one partition and second core will be taken to the second partition. So the first core will take only the partition which consists of males. The second core will take only the partition which consists of females. But you need to get it out. Rohit, how it is taking only means how Spark is recognizing that I need to take all the genders of male to one partition and all the females to another partition. Here comes a concept called as hashing, not hashing. So here comes a concept called as hash aggregations. Okay, which will be having some link between the hash bytes. What is hash aggregations and what are hash bytes? Okay, let us discuss about that. Okay, but before that, you need to discuss about what is shuffling of data. Okay, what is shuffling of data? Okay, if you want to, I think I have written about hashing. Yeah. So okay. So before going to hash bytes and as well as hash aggregations and all, you need to understand what is shuffling of data. Shuffling of data means what? This part. Okay. What is the shuffling of data? Shuffling of data is the process of redistributing the data across the partitions. Just now I have discussed. So we will take the data from different input partitions and we'll shuffle the data and distribute to the output partitions which are there in the what we call it as executors. So data shuffling is a process of redistributing data across partitions in a Spark cluster so that the records with the same key, see, records with the same key means what? Before we are having gender, it consists of male, right? Male is the same key. So the records with the same key are grouped together for operations to perform joins and as well as sortings. So now I want to give one clarity for everyone. Like narrow transformations are simply selecting the queries. Narrow transformations are, I'm writing over here. Narrow transformations are simply, see, narrow transformations means simply filtering the records. Okay, filtering the records as per partition. So selecting the records. Selecting the record, so and as well as, so there are so many individual operations are there that will perform, so all those things comes under narrow transformations only. Okay, but when it comes to the wide transformations, wide transformations wide transformations, okay, when it comes to wide transformations, see, when you're doing group by, okay, when you're doing aggregations, when you are performing joins, because group by, if you are doing group by, see, before we have done group by only, I have told what is the second question I have asked na, what is a max salary of what we call it as males and females and count of this one, this is an aggregation. If you want to do, you need to do group by only, you need to do shuffling and all, and finally here all the data will come, here you will apply group by, here you will apply group by. Now you will apply group by and now you will sell, okay, in the entire mail I'm having a count of five males are there, and as well as I'm having four females. Now like that you can able to tell aggregations. If I want to know what is the sum of salary of females and what is sum of salary of males, that is what aggregations over there. So if you want to perform aggregations and all, and joins also, which means joining other tables and all. So if you want to join other tables and all, for sure you need to do shuffling for sure. If you are not doing shuffling, how you will get the data and all? So what you will do means, when you are performing aggregations, when you are performing group bys, blah blah blah, rest of all the things, you need to take one key column where you need to perform, by that column only you need to, you will perform group by, you will perform aggregations and all. By using that key column, we will transfer all the data to output partitions, and that is also not easy. Okay, that one also I'll tell you how it will work. Okay, now before that, first make we'll make our basics strong. Okay, now when comes to white partitions, now as I told, where because of this so much shuffling of data between the partitions and all distributing of data, first of all it is slower compared to narrow transformations. Okay, because there is lot of data movement will be there between the nodes. And there are so many stages that are created in the Spark jobs. I'll let you know what are stages and what are what we call it as tasks and all. What is a job? Coming what we call it as in the coming topics and all. Okay, and what it will do, it involves the disk space and as well as network communication. And because of that, the cluster the usage of cluster will also be very high. Because of that, there will be a lot of money also will go. So before applying byte transformations and all, we will apply some what we called as optimization techniques, okay, called as broadcast join, caching, salting, persisting. There are so many things are there, okay. So we'll do like that, okay. And we use this byte transformations as I have told for grouping and as well as joining. Okay, this is an example for that. Okay, as I have told. Now, when it comes to shuffling of our data, as I told that we will what we call it as it is redistributing data across the partitions in the same cluster so that the records with the same key. Same key means what? Whatever the aggregation key is there are grouped together with the one partition only, output partition only, what to perform group by join and as well as sorting. Okay, now why shuffling is required? This is what most important question also that will be asked in interview. Why I need to perform shuffling? Means shuffling is required when an operation needs data from multiple partition. Okay, when an operation means your final partition, or if you want to perform any group by, that's an operation, right? So if you want to perform a group by and you want to take the count, sum, average, max, min, so if whenever any other dependency is there in other partitions, shuffling is a must. So from multiple partitions to combine or compared with that, okay, because the partitions will get compared and they will combine together and the data will be shuffled. Okay, why to aggregate data with the same key? Because if I need to do aggregation na, I need all the people to all the mail to sit in one partition. Then only I can make a group by. If not, all the people are messy. How can I make group by over there, right? Spark couldn't able to understand. So to make that one, and as well as to join two data sets based upon column. This is joining. If I'm having two data sets, for suppose let us take our fee payment table and as well as our department table. If I want to join two data sets, how you could able to, for suppose if one data set is sitting in one partition, another data set is sitting in another partition, how you could able to make join with that? It's a very tricky thing. So because of that, what we will do, we'll make this kind of shuffling. Okay, you will get to know about joins and all. Joins and all, you need to understand how joins applies in Spark. Okay, now without shuffling, Spark would only process the data with individual partitions. See, whatever the individual partitions are there, that will only be it will process, and that is impossible. Everyone know how it is impossible. See, I'm having here two males, one female is there, two males, two females are there. What it will do, it will process the same data over here, that will become an arrow transformation. And with that, it will you could be able to understand or could be able to what we call it as do group bys and all, that is impossible. Same thing only it is been explaining over there in that shuffling of data. Okay, now what happens in the shuffling? What happens in the shuffling? How shuffling means how the Apache Spark will understand that how means this. Okay, these are mails, I need to transfer all these mails to this particular group, and these are females, I need to transfer all these females to another group or another partition. How he will get to know? There is something called as this particular formula that used by Spark. Okay, how it will get to know? Okay, see, I'm drawing whatever these two output partitions are there na, this partition and as well as this partition 1, partition 2, I'm drawing below once again. Okay, over here, not completely, just like that. Okay, let me draw this one, let me draw this one. Okay, two partitions are there. How Spark will get to know? That is a major question. Okay, let me draw over here. Partition 1 and partition 2. Okay. Before this, you need to understand, okay, something called as, this is a formula, okay? Partition ID. It will segregate with respect to the partition ID. Every partition will have one partition ID. So that will be generated by this hash key. Okay, how it will get generated? So as I have told initially, when you are performing any white transformations, defaultly when you are performing any white transformations, white transformations means what? White transformations means what? White transformations means group by, okay, filtering, not filtering, group by, aggregations, all these things. Whenever you are performing any white transformation, Spark will defaultly create 200 partitions defaultly. Okay, 200 partitions it will create, it make defaultly for you. Okay, and what it will do means, see, I am having two partitions over here. These are my output partition. Okay, this is what, this is my partition 1 and this is my partition 2. That's it. Okay, now what Spark will do means, whatever the I have told now, there will be one hash formula that was written over here. What was that? Hash key. Partition ID is equal to partition underscore ID equal to hash, and it will do key. What is this key? Key means this is a column name. Okay, this is a column name where you want to do the group by and all. Okay, where you want to do the group by and all. And after that, you need to give this particular percentage, not mod. Okay, you need to give the mod. Okay, let me provide mod with respect to the number of partitions available. Example, see, we have, with respect to what I am doing group by with respect to my, what we call it as gender, right? I'm doing group by with respect to my gender. What it will do, it will take hash of gender. What is the initial gender of mine? It is male, right? What this hash will do, or what this hash bytes will do, it will convert my whatever my integers or my strings into a what we call it as binary bytes. Okay, these are hash bytes, but there is not that much connection is there. What hash bytes will do, they are the binary bytes representation of hash value. This is a hash value. What they will do, it will convert whatever my string or anything is there into some bytes, 110 like that, some bytes it will do. Okay, it will convert like that. Okay, once it converts, like that, what it will do means, see, what it will do means, for suppose if I have given mail of this one, right? Okay, for suppose it has converted my mail, it has converted that hash into some value called as 2 or 10 or 110 like that. Okay, 110 like that. Okay, consider you are performing this, what we call it as byte transformations. Not when you have given this byte, do not think about it. Okay, bytes means, okay, let us clear it off, let me clear it off. Hash bytes means whatever the integers or string values you are having, it converts that into binary bytes. Binary bytes means computer only knows 0 and 1, so it will convert that into 0 and 1 language. Okay, if you have given mail, it will convert this into a binary number. Okay, binary number means consider like as 2 101. Okay, like let's see, 010, no, not like that. 100, 1210, like that. It will convert like that. Okay, it will convert like that. Okay, let me take it, convert it into like what I can say, something called as 303, 303, like that. It converted 303. It converted like that. Okay. So when it converted my hash, this one into binary number, m into binary number, and I'm doing mod of number of how many partitions are available for me. 200 partitions are available for me. So it will take the reminder. So till here video cut. From now I'm starting. Okay. So see what this binary bytes will do, not binary, what this hash bytes will do or hash will do. It will convert my integers or strings into my binary bytes or binary numbers. Okay, it will convert my mail into one binary number, something called as, let us take 203. It is its own wish. Okay, you can't decide that what number it will create like that. Okay, own wish. 203 percentage of number of partitions available. So how many partition that Spark has created for me? 200 partitions it was created for me. So out of 200, 203 percentage 3, what is a reminder that I will get? 3. Okay, and this will be your partition ID. Okay, this will be your partition ID. And what is for the second gender? It will do hash hash, and it will perform same thing for female also. Okay, it will perform same thing for female. For suppose let us take female has given 201, 201 percentage of how many partitions are available. Already one partition is been taken, right? Already one partition is been taken, so it will take 199. So how many times it will go? What is a reminder it will get? Reminder will be what? 2. So this 2 will be the partition ID. Okay. And now what it will do, every time this is the initial calculation it will perform. Initial calculation it will perform. And every time what it will check, whenever it is checking each and every row in the partition. Okay, whenever it is checking each and every row in the partition, first of all it will check m. Okay, m means every time it will get only one number, and with that number how many available partitions it will do, and it will have one id, same id you will get partition 1. So that it will, the male will get transferred to this partition 1, and like that the female also will get one constant code for each and every gender. So here the key column is very much important, that which column you are doing the hashing and all. So this is what hash key, this one. So initially what it will do, it will just map the partitions and all. Map phase means this is a map phase. Okay, once map phase is done, it will do shuffling with respect to the key column by taking the key column. That's it. Okay, it will take key column, and it will perform, it will generate one what we call as code or anything for that particular row which is having. And for each and every one, how many mails are there, for everyone will get the same number only. If I do with the particular available partitions and all, I'll get same partition id only. So all like that, all the mails will get pushed to the particular partition id 1 and partition id 2. Okay, so with this reference. Okay, so what is this? Here I have taken partition id 3, so I need to give partition id 3. So like that, all the persons who belong from male will go here, and all the females who got 2 id will go here. This is what the main concept of how Spark will recognize that only these people I need to send to these partitions, these people I need to send to these partitions. Same thing I have written over here. See, this formula determines which partition a particular record should be sent to based on its key. Hash key means what it will do, converts the key into a deterministic integer, one value. Number of partitions means total number of partitions available. Modular, what modular will do? it will what called ensures that partition id is within 0 to 1 range only. Okay, we need to give like that only. It should be either 0 or it should be either 1. Okay, now what Spark uses over here to make this one? Okay, Spark uses something called as what we call it as there is something called as hash aggregation it will use. I think that one also I have explained in between. Yeah, now, Spark uses this mechanism to ensure that all records with the same key are sent to the same partition. Okay, which is essential to perform operations like group by, reduce by key, and join, district, repartition, all these things and all. Right. Now, let us take an example. There is one input data is there for 10 Rohit, 20 Tarun, 10 Vardhan, 30 Ravi, 20 Sudhir and all. Okay. Let us take I'm having three partitions are there with me. Not 200, three partitions are there. Okay. After applying hash key, okay, if I apply a hash key, the zero, because the Rohit will generate something called as with respect to ID I will create. So for 10 I'm taking, I'll get something called as zero partition for 30 Ravi. Okay, Ravi will go over here. Two 20s are there which will get the same partition ID of partition 1. It went over there. Partition 2, 10 and 10 like this. Recording now. Yes. Okay. Now if you come down, okay. What is a hash aggregation? Okay, I told there is something called as hash aggregation window. See, each and everything I'll show you in practical. Okay, first of all, try to understand what this one. See, hash aggregation is a query execution technique. Okay, what it will do, it is used in systems like Apache Spark, Hive, SQL databases and all. Okay, what it will do, see, whenever after shuffle happens na, it helps to perform the aggregations out of it. Like, see, I have told now, all if I combine all the mails, I got 5 mails like that. Okay, so if I count all the females, I got like that. If I do sum of all the this one salaries, I'll do. So to perform this kind of aggregations, hash aggregation is being used, and you can see this in detailedly in my Databricks also. So hash aggregation is a query execution technique used to systems like Apache Spark, Hive, SQL databases to efficiently perform group by and aggregate operations like sum, count, average and all. Okay, how it works? Okay, how it works means, see, there will be some hash table is created in the memory, and see, this hash table will be there in joins also. So there will be one hash table will be created in the memory, and after this what will happen, whatever the grouping key will be there, grouping key means here my grouping key is gender. Okay, is hash to determine where to store the aggregation result, and it will fetch all the result. And what it will do, if the key already exists in the hash table, okay, the aggregate value is updated, otherwise a new value will be created. Okay, what it will do, let me tell you with detailed example. See, there will be one hash table will be created in the memory. Okay, one table will be created in the memory. Okay, one table will, this is what, let us take hash table. Let us take hash table. This is what hash table. Okay, what this will do, this is hash table where it creates in the memory, not in disk. Okay, what it will do means, first of all, it will check it will check with your what we call it as after once the whatever the shuffling is being done, it will go and check with this one. Okay, it will go and check with this one. Okay, with your your shuffled outputs of male and as well as female. Okay, what it will do means, see, whatever the grouping key is there, grouping key is what, this particular male and female. Okay, what it will do, if my particular uh, key already is there in the hash table. Okay, what things will be there? Male and female, all these things will be there. Okay, if my key is already there in the hash table, whatever the aggregated value will be there, that will be updated. If not, new entry will be done. Okay, what this means, see, for suppose initially Rohit is there. Okay, this one is there. Let us take the output partition over here. Okay, this record I don't have in my hash table. Okay, what it will do, new record will be updated. And second time, Rohit and Shiva, when it is reading Rohit and Shiva, this value is already there, male is already there with the key column which I am mentioning. Okay, so what it will do, it will just update this value over here for Shiva, and it will do start counting it as per my aggregation that I am doing. Okay, again, this Chandu and this one, mail is already been there, so it will only add this one over here. It will update this one. Okay, and what it will do, it will update, and every time it will calculate the count. If comes to Chandu, it is 3, after it is 4, after it is 5, like that. So finally it will give 5 for you. Okay, this is what how it goes. Every time it will update the value, it will not add the new value. Once this is been done, when it comes to the output part 2, it will say, okay, the gender is not there, so it will add this one. Okay, what it will do, it will make a count of 1. Yeah, okay, fine. After that, what? Dina, because gender is already there. Okay, it will take Dina. Yeah, it is, what is a count? A count is 2. And it will take Nageshwari. It will simply update it. That's it, Nageshwari. And it is 3. Like that it will go for Reshma and 4. Like in this manner it will do aggregations and all by using something called as hash aggregation key. Same thing he is explaining over here. The grouping key is hash to determine where to store the aggregation result. If the key already exists in the hash table, the aggregated value is updated, otherwise the new entry will be done. This is what about hash aggregations. Okay, now this is what we call it as data shuffling. What we call this one, I already have read it. Data shuffling in Apache Spark is the, because interviewer most of the times he will ask what is data shuffling, why you need to do the shufflings and all. So data shuffling in Apache Spark is a process of redistributing the data across the partitions to ensure that the record with the same key are grouped together and all. You know this one. Okay, let us not do time waste. So these are hash bytes. Hash bytes we are discussing. Hash bytes are about identifying or verifying the data. See, hash bytes is a different concept. Okay. What hash bytes will do? Hash bytes. Okay, let me explain that one also for you. Okay. What hash bytes will do now? For suppose I'm having some name called as Rohit. Okay. When I'm passing my name, okay, for suppose I'm having some password. Okay, like this. Let us take this is my password. Okay, if I have taken this password, when I'm passing my data throughout the networks and all, there will be not that much security will be there. Okay, because mostly we use hash bytes to do validations and as well as to for security reasons also. Okay, if I get a Rohit 2000, what it will do, it will convert my name into something called as hash bytes like this. You could have seen this one. This is a hash byte. This is what, this is a long what we call it as hash value that got created, and this will go across the missions and all. Why we use this hash bytes to do data partitioning. So deduplication means not allowing the duplicates and all. If already one value is there, for that value one particular hash byte will get created for that. Okay, if again same value will come, same hash byte will get created and it will not allow also, and it first of all it will not allow to recreate also. Okay, because every hash byte is a unique hash byte. Okay, and it is used to create a surrogate keys. Future you will understand what are surrogate keys and all. Okay. No, now now if you see over here, now if you see over here, hash bytes are about identifying or verifying the data. Hash aggregation is about efficiently grouping data from computer. computation. These are the two differences. Okay. Now, what is a now let us have one quick revision on this particular narrow transformations and wide transformations. Okay, if you see that narrow transformation doesn't perform any shufflings and all, and these are faster because the data is flowing from one out input partition to another input partition. There is no shuffling happening between them. Okay, and it is faster. Single stage stages you will get to understand it just if examples like mapping, filtering, this select, these are the examples of it. Why transformations? Shuffling is required, slower, because the data flow need to flow between one partition to another partition. It will go to multiple stages. You will get to know what are stages and all. What are types of shuffles in Spark? Two types of shuffles are there. Okay, hash shuffle, short shuffle, short shuffle. Okay, these will you will we will cover in joins part, which we are going in further topics. Okay, uses of hash function to determine the target partition. See, just now we have done hash shuffling only. Okay, whatever the shuffling we have done by using one hash key and all, this is a hash shuffling. Okay, with respect to hash key, we'll do mod with respect to number of partitions. If how many partitions are there, we will do shuffling like that. Based upon that, we will do shuffling. Because see, doing shuffling is one part, but you need to know, if you're doing shuffling, you need to, if you're taking data from one part and if you need to shuffle to another part, you need to know the destination also. To determine that destination only, this hash shuffle and sort shuffle is there. Sort shuffle means, sorting means what, making data in order. Okay, you will get to know this one, do not worry about it. Okay, but just make a note out of it. Okay, now this is very important concept, which is partitioning and repartitioning. Okay, partitioning and repartitioning. What is partitionings and what are repartitionings? Okay, and first of all, let us discuss this concept. Okay, once everything is been done, we'll jump to Databricks, and whatever the concepts we have discussed till now, we'll go one by one in that, by looking all the DAX, everything in a practical manner. Okay, now come boss. Partitioning and repartitioning. Partitioning means what? As I have told, partitioning is a process of dividing a large data sets into smaller manageable chunks called partition. These are the definitions that I have kept. You can note it down. Okay, which are redistributed across multiple nodes in a cluster for a parallel processing. Okay, which are distributed across multiple nodes in a cluster for parallel processing. Parallel processing means what? Cores. If I'm having four cores, four cores will run parallelly. That is what we call as parallel processing. Okay, now for the data frame. Okay, for the data frame. Okay, see, we can set. Okay, there is something called as spark.conf.set. Conf means configurations. There are some configurations are there that we can set in Spark. Okay, spark.sql.shuffle.partitions. Okay, this is one of the configuration which is available in the Spark. Like that, there are so many configurations are there. So we can set the number of partitions. We can change the partitions size also, like 100 partitions like that. Okay, we can change that one also. Okay, now first of all, if you have created one data frame, okay, you read one data, and you need to know that that data was stored in how many partitions. To know that one, you need to type this one, dd df dot data frame dot rdd dot get number of partitions. You will get how many number of partitions my data is being stored. Okay, sorry. Now if you want to, this is for data frame. I told before, we are having RDDs. Writing code in RDDs is not recommendable, because we simply write our code in data frame and that gets optimized at the end, and that info will be given to the RDDs. Okay. Sorry. If you anyone don't know this one, let me explain that in before stages we used to write the data in RDD. We don't have columns and all. So now we are writing our data in data frame, and what it will do, that data will be optimized by Spark, and whatever the plan or info will be there, that will be given to RDDs. As I have told, the driver node will give info to RDDs. The RDDs will split the data into number of partitions and distribute across the executors and all. I think everyone knows, right? Now, how many types of partitions are there? This thing already we have discussed. The first type of partitioning is a hash partitioning, and the partitionings will be done this one called as by using hash key. This one we have already been discussed. Okay, what it will do, distributes data based on a hash of the key, ensures that records with the same key go to the same partition. This is what hash partitioning will do. Hash key, whatever the value I'm giving, integer, it could be integer, it could be data, it could be my what we call it as string values, it converts it to a integer value, that will be taken mod, or that will be uh, done division with respect to the number of partitions, and finally it will take reminder out of it. And what is a reminder that we get, that will be treated as a partition id, and for all the group of that partition key, it will maintain the same id for a group of people. Like I'm having females and males got mixed up, for all the people it maintains in the same manner, and that data will be what we call it as, those data people only will get driven to the partition. This thing everyone know, this is what hash partitioning. Example, df dot repartitioning, I'll tell you. Okay, no issue. What is a range partitioning? See, what range partitioning means? It distributes the data based upon the value of ranges. Example, if I'm having salary, okay, what it will do? If I'm doing repartitioning means with my own requirement, I will do partitions. That is what repartition. Okay. Here, if I'm simply, if I need to do the hash partitions and all, I will do df dot repartitions 4 of department id. If I'm giving like this, okay, which means if I'm giving like this, okay, repartition means with respect to my own, I can decide how many partitions I want. I'm creating 4 partitions for this department id. With respect to what I'm creating partitions, hash keys and all. Same if I applies to range partition. If I am doing 4 partitions for salary, see, salary, every salary will be unique. Some people will get matched, but most of the peoples are unique. What it will do, it will take from 0 to 1000 one partition, 1000 to 2000 one partition. It's not like that. I'm telling example. Okay, some 0 to 1 lakh like that one partition, some 2 to third like that. It will take partitions like that. Okay, like that it will split 4 partitions neatly. Okay, next comes the part of, I hope you understood about what is a partitioning. Two types of partitionings are there, hash and range partitioning. Custom partitions are there, but that we use an RDDs. Now we are not using it at all, because there is something called as Spark AQE came, adaptive query execution. Okay, that is a Spark automatic Spark optimization technique. Okay, which we do not need to do anything. All the optimizations will be done by Spark. Spark will decide how many partitions your data needed, and it will give automatically. Okay, it will say, boss, why you need 200 partitions for y trans. See, every time I don't know, when I create do any y transformation, Spark will give 200 partitions defaultly. But but AQE will not allow you like that. AQ tell that, see, your whatever the you are having 5 rows, 5 rows, one partition is also very huge for you. Why you need 200 partitions? Take one partitions and adjust. It will give like that. Okay. This is what AQE, but AQE will discuss in our further topics and all. But now let us concentrate on what is repartitioning. Okay. So now we are going to discuss something called as repartitioning. What is this repartitioning? See, repartitioning is a process of changing the number of partitions or redistributing the data across the partitions after the data set has been created. Like example, see, I told that there is one default partitioning size is there 128 MB. So once if the Spark recommends you to create one partition within 128 MB, if that will get exits, if that get exceeded, Spark will create another partition and that will do like that, right? But if I want to customize the partitions, if I want to increase the partitions, so at that time I can do something called as repartitioning. Why repartitioning means to increase the parallelism. Parallelism means what? If for suppose if I'm having 10 records are there, okay, 10 records are there. I'm having two worker nodes are there, okay, 10 records are there. Let me take. I'm having 10 rows are there, okay, and I'm having two worker nodes are there, okay, and each worker node is having how many cores are there? Four cores. 4 plus 4, 4 plus 4, total how many cores are there? Total 8 cores will be there, right? So what, according to that, each core will take one partition, okay. See, 10 rows means it will not give to 8 cores. 10 rows means hardly it will be there in kbs. That file will be within one partition only, it will adjust everything. But no, for some reasons you want to increase the partitioning size, okay, you want to increase the partitioning size. For 10 rows, what I have done, I have increased it to like how many partitions I can do means I want to uh, do this one for 4 partitions, okay. So I have created one data, so data frame df dot, first of all I have read it spark dot read dot format, something it is CSV file, and all that infer schema and all. Finally I have done load of the this whatever my file is there. Let us take employee emp underscore tbl. This is my file which has 10 employees, okay. But for some reason I want to increase the partitioning sign. So at that time what I can do, df is equal to, I will do df dot, see defaultly if I leave like this na, it will just do one partitioning only for you. But if I want to do departitioning, I want to do df dot repartition, okay, of how many partitions you want to do for this particular df data frame. So this df data frame defaultly having one partition, but you want to do 4 partitions. If I give, for suppose if I want to do 4 partitions, this data frame will do 4 partitions. So the for 10 rows it will adjust within 4 partitions, it will goes means it will go to 4 cores to increase the parallelism. This is what the meaning of to increase the parallelism. But there is one disadvantage is also been there, because you will get to know in tasks what are jobs and tasks. At that time you will get to know what is a major disadvantage that you are going to face if you increase the number of partitions, okay. That is a very much what we call it as tough thing, okay, to do. Let me start this cluster, okay. I'm not started yet. Let me start my Databricks cluster. Meanwhile we can discuss some concepts, okay. Now, so if okay, this is what about repartitioning, okay. There is something called as repartitioning and as well as something called as coalesce. There is something called as repartitioning and coalesce. See, first of all, if I want to get for my this df data frame, first of all, let us, before doing repartitioning and all, if I want to check how many partitions are there for this df data frame I have created, okay, I want to do df is equal to, okay, df dot rdd, rdd, because rdd will only do partitions, dot get, what I need to do, number of, I need to do partitions, okay. Obviously it will give one partition only for you, that your data frame, because it's very 10 employees means hardly boss you get only 10 one partition only, okay. If I want to increase the partition size, okay, if I want to make my data into what we call it as number of, if I want to increase my partition size, At that time what I will do, I will simply I will do df dot repartition. I want to do repartition of 4. So if I do repartitioning of 4, whatever my one partition is there over here, that will be done go to 4 partitions over here. Okay, which means that two employees will two three employees means here first employee yeah. Just a second. Okay. Okay, first employee. Okay. Hey, first employee, second employee will lie over here. Okay, and the third employee will lie over here. Okay, 4 5 6 will lie over here, like that. 7 8 9 10, all the people will get adjusted like that. Okay, this is what about repartitioning. What is the meaning of coil is then? There is something called as coil is, which I didn't mention, which is very important. Co coil is. Okay, what coilis will do mean, see, whenever you are having number of partitions, see, you got realized that, see, for 10 records 4 partitions are not required. So I want to convert all these partitions into one partition. So at that time you will get coilis. Coilis will merge all the partitions and it will decrease the size of number of partitions. So that is what the meaning of coil is over here. See what coilis will do means, see, now I will do df dot, or df is equal to df dot, or I will create one new data frame. Df is equal to df dot. Okay, what I will do, coil is, and I will decrease this to 4 partitions are there now. I will decrease this to 2 partitions are enough. 5 by 5, you 2 split 5 by 5. So what it will do, it will only give 2 partitions and it will split. Okay, how you can check all these things? There is one command called as, df dot explain. If you just click this command, you will get to know each and everything. That's it. Okay, this is what about partitioning, so repartitioning, so shuffle, all this part. I hope theoretical part is fine for everyone. Now let us, there is something called to discuss about the practical stuff. Okay, so let's, if you are having any doubt in this part, please rewatch this part again and again, so you will get to know. Okay, now what is our main thing to do over here is, before going into the joints and all, we will first discuss about the repartitioning, still repartitionings, because you will also feel a lot of bored. And let my cluster get started, so I will start with the things. And before the things, I will tell you few things, like, see, I have told something called as AQE, right? Adaptive Query Execution. This is a new Spark optimization technique, which Spark optimizes everything. Okay, whatever the queries, whatever the transformations that we are doing, Spark has a capability to optimize automatically. So first of all, we need to disable that one, so that we can able to view whatever the things that we are performing. If not, now see, if I increase my number of partitions to 5 partitions, okay, for having 10 rows, Spark will say, why you need 10 partitions for 5 rows? So to do that one, what I need to do, I need to disable that one. Even my cluster also got started. My, you know, everyone, my cluster has 16 what we call it as GB and 4 cores. Okay, first of all, to disable that one, see, I told there is something called as spark.conf.set. To set the configurations, I need to set the configurations. And what I'm doing, there is something called as Spark SQL adaptive enabled. I need to make it false. First of all, I need to do this one. Okay, and and I need to check what is the status of it. See, whenever if I want to disable, enable, or change the configuration, I need to write spark.conf.set Spark SQL. I need to write what is a configuration. whether it is true or false. If I make it true, it is enabled. If I make it false, it is disabled. And if I give spark.conf.get, get means what is status of this particular configuration, I need to check. I need to get false over here, so that I could able to happily I can view that okay, my AQ or my security guard or my optimization auto optimization tool is disabled right now, so I can view whatever the transformations are there, I can view happily. Okay, now first of all, let me read the one file. Okay, let me create one data frame. Df is equal to spark. As everyone in the first session I have discussed, spark, if I write spark, automatically it creates one data frame for me, right? Not data frame, spark session for me. Okay, read dot format. What is the format of mine? Format is there of CSV format. Okay, now I want to know all the infer schema. These things I have already explained. Okay, dot option, and I need to write header, comma, true. Okay, now I need to come down and I need to give dot option. Okay, infer schema, comma, true. I need to make it true because I need to take my Spark auto, what we call it as schemas and all. Now I need to load my data. From where I need to load my data, let me do duplicate this one. Okay, I need to go to my catalog where I have saved all my things and all. Let me go to my sample catalog. I think sample schema in volumes, sample volume, I think so. Order CV, orders.csv. This is a file that I want to read. Okay, now I want to just copy this one. This is there till samples, and at the last I need to provide, okay, something called as orders.csv. This thing I need to provide because this particular file only I'm reading. Okay, let me run this one. As I told, if I'm reading anything also, Spark creates a job because read is also one what we call it as action command. Here if you see, two jobs will created for me. Two jobs will created because one job is read, sorry, this is one read, this is one job, first job, and infer schema is a second job for me. So these are also infer schema and read, these are also the action commands. That's why here it will not perform any lazy evolution or anything, it will directly gives you the things. So that's why if you see, two jobs got created for me. Job 0 is to read the data, job 1 is to do the infer schema. Okay, we'll get into the stages, no issue, we'll get into the stages. Okay, now if I come over here, I have read my job, I haven't seen any data or anything because it's a lazy evolution. If you see this one, you will get all the item orders, whatever all the there. Okay, first of all, let us go with the filtering the data. Okay, filtering the data, what we are doing filtering the data here. First of all, let me see in my below one, above one, because already I have taken that already above, and I think I already have got the data. What is the data which is available for me? Because okay, let me do df dot display. Okay, display, let me display my data. This is my action command. So till here one RDD will get created for me. Okay, and one job also will get created for me because action command is also one job for me. Okay, and before that what I will do, df dot explain. See, this is one explain command. It will explain you about the tag. Nothing we have done over here, we have just read the file. Okay, and as well as we have displayed it, that's it. So if I want to view that one, if you want to view the plan, simply do explain. So in df dot data frame only your thing is there. So it will display you this one. This is what the physical plan. What, why physical plan is given to you instead of logical plan, I have told you. When you give action this one, Spark will optimize your logical plan into physical plan, and that physical plan will be given to you. What physical plan it has given to me? So one file has scanned, file scan of CSV, and what it has scanned, it has scanned these columns of order ID, order date, all these things. And any filter, data filters got applied over here, no filters, nothing. Okay, any partition filters, nothing. Okay, and as well as what is this read schema? Schema means this is a data types that got applied to me. Okay, and where it is there, it's been stored in the in-memory file index. It is not stored in the disk, it's stored in the in-memory file only. Okay, and what is a format also, it is been there. So like this you need to read the plan. Okay, now let us apply one narrow transformation. Okay, transformation. Okay, let us apply one narrow transformation. Okay, narrow transformation means what? Filtering. Just I want to filter the record. What I am filtering over here means, see, let me filter the people who belongs to only fashion industry. Okay, I want to filter only the people who belongs to fashion industry. And before this, let me check how many partitions are there for my df. Okay, what I will do before doing the filter, okay, I'll do one thing, that I will first of all check for my whatever the data CSV I have read. I will check how many partitions are there for that. Okay, what I will do, df dot rdd dot re rdd dot what I need to type, df dot rdd dot get number of partitions. Yeah, that's it. If I ran it, I'll get only one partition because my file is very small file. So Spark will automatically tell boss, do not do much. Okay, you'll be in trouble. Okay. Now next, what you will do, for you one partition is very much enough for you. Take that partition. Okay, that's it. Fine. Now what I'll do, total how many records are there? You see, if you see, total I'm having 1001 records are there with me. See, for 1001 rows, it had given me only one partition, if you have seen it. So there are so many partitions also will be there. Okay. Now what I'll do. Sorry. Now what I'll do something called as filter. Now I'll do df underscore filter. If I write like this, one new RDD will get created for me. Okay, you will get to know how it is. Okay, df underscore filter, df dot filter. This is a filter command where I'll use to filter it. Before doing it, I want to import my functions and as well as this one also. Okay, from spikespark.sql, import all the functions. Okay, let me run. Okay, that's it. This one run. If not, now it will not run because you need to import the that column. If not, it will not run. So which column you want to take? Which column I want to take? I want to take uh, product category, and I want to take how many product categories are there and only in fashion. How many user IDs or whatever the people are there. Okay, fashion. So product category. So let me take column of product category. So let me write product category equal to FASHION fashion. If I have ran it, okay, if I have ran it, this is a narrow transformation because it having only one partition only. Okay, nothing will happen. So nothing, as it is told daisy evolution, nothing it will do. Okay, now if I do df underscore filter dot display, if I ran this action command, now you can see there are some jobs got created for me. One job got created. In this I have got all the people who belongs to fashion industry only. Okay, Now if I click on this one, I have one job 9. Okay, I need to view this. Okay, I need to view this. So if you have gone over here, you can see something called as jobs, stages. You will get to know what are stages, what are tasks. Okay, so jobs means only one job that got created to filter this one, and that one also got succeeded. The total task is succeeded. See, what is the input? Input is also very less amount of storage I'm having, so that's why it had created one partition for me. Okay, and only one stage got created. You will get to know why one stage. Okay, now stages. If you come to stages, there is only one stage only got created for this one. Okay, let me tell you, explain you about the stages and all, but before that let us view the DAG out of it. If you want to go to DAG, you need to go to SQL data frame. Simply go to the job 9 df underscore filter dot display. If you click on this job 9, you will get this DAG. What this has done, by viewing this DAG only, last time also have discussed, by viewing this DAG only, the RDDs will create the partitions out of it. Okay, and it will distribute the data to the executors. But here we are having only one single node, that both driver node and as well as worker node are acting as single node for me. Okay, here I'm having the scanning the CSV records. Okay, nothing. It will show how much it is there and what is a cloud storage response size I'm having, and how many columns it had read. Everything it will be visible over here for you. See how many columns it scanned. Total 10 columns are there with me. 10 columns it has scanned. And if you see, partitions columns are 0. Do not think about it. 0 means it starts from 0th partition. So that's why it had given like that. How many files it had read? One file only it has read. Okay, and you can see one more thing. What was that? Rows output. How many outputs it had read? 188 outputs. Let us check that we got 188 rows as output or not. Okay, see how many outputs are there in fashion? 188. If you see over here clearly, 188. So those many output it had read. This is all scanning of CSV tag. Okay, optimized plan. After this, everyone know it has filtered the data. Only it had taken the fashion brands, rows output 188, and finally it has done the coilies, or it will collect it. Okay, it will collect the things. Map reduce I have told now, like that. So it has done. Any shuffles have done now? Here now you can able to understand. Any shuffles have done? No shuffles. Any merge chunks means partitions only. No, nothing has done. So that's why everything is kept 0 over here. Okay, but before proceeding to the next one, okay, let us understand about the jobs and stages, because why transformations requires jobs and stages, which is very important to learn that one. Okay, now let me go to my over here. You will get to know everything. Okay, now, see, as I have told, whenever I hit any display command, df.display, or any action commands like writing the data, reading the data, or anything, one job got created for me. Okay, if I go over here, what happens after job gets created for me? This is what the important thing that you need to understand. Okay, what happens after job creates for me? Okay, now see, whenever job creates for me, within the jobs, okay, within the jobs, there are so many stages will be there. Okay, stages means transformations. How many transformations we have performed? Those are stages. Simply stages. Okay, within the stages, tasks will be there. Okay, let me write it sidely, that within the stages, ta within the stages, tasks will be there. How much the time? 2 hours over. So within the stages, tasks will be there. See, whenever I have created any job, within the job, I have multiple stages. Stages are nothing but transformations I have done. Okay. And within the what we call it as stages, I'm having number of n number of tasks. I'm writing n number of tasks. Do not think that like only one task will be there. Okay, now let me explain what are stages. Okay, if our transformation is not changing, okay, what stages will do means, here I have applied only narrow transformation, right? If I have applied some group by, next I'm going to do that one only. Okay, group by is a wide transformation as we have discussed. Okay, now see, if I have done some narrow transformation, for all the narrow transformations, similar kind of transformations, one job, one what we call it as stage will get created. Okay, this is stage one. Okay, for all the kinds of what we call it as this wide transformations, another stage will get created. Another stage two. Understood? There are two stages will get created. So for all the similar kind of, okay, see, for suppose if our transformation is not changing, I have till now I have done only one transformation, that is the narrow transformation, right? I have done only narrow transformation, one filter. So it will not create stage 2 for me. It will create only stage 1 for me. And within the stage 1, how many tasks are there for me? Task means the number of partitions. Okay. The number of partitions. How many partitions are there for me over here? I'm having only one partition. So only one task will get created for me. Okay. Only one task will get created for me. Okay. Task 1, and that task will be given to the executor or the core. This will be given to the core. This will be given to the core. Core 1. Understood? Core 1. Task means nothing. One partition is equal to one task. Simply see, it's a blind rule. I'm telling again. See, one task will have one partition, and one partition will be handled by one core. That's it. One task will be handled by one partition, and one partition will be handled by one core. That's it. Okay. For suppose, see now, as I told, how many, if I perform this stage 2 is wide transformation. Okay. Here I have applied group by. Okay. Here I have applied group by. As I told, uh, the tasks are directly proportional to the how many partitions that got created. As I have told, when I have done any wide transformation, how many partitions will get created for me by default if my AQ is off, if my AQ is on. Okay, initially I have disabled my AQ in a, if I won't disable my AQ, if my AQ is on, it will not give 200 partitions for you. It will simply say, boss, your file size is very low, take one partition and leave. That's it. But I have turned off my partitions, so you can see 200 partitions which got defaultly created. So if I'm creating 200 partitions, how many tasks will get created for me? 200 tasks will get created for me. Okay, 200 tasks will get created for me by default. Okay, so one task, okay, like that, two task, okay, three task, third task, like that, 200th task. Okay, it doesn't mean that my data will reside in all the tasks. No, that's not the right thing. You'll get to know what happens if I'm having very lower data, how we will store the data in those many partitions and all. You will get to know in few sometime. Okay, now you need to understand one thing. You need to note some points. The first point is, if our transformation is not changing, okay, like if my entire flow is under narrow, or if my entire notebook is under wide transformations, so all the narrow transformations will go to one stage. Or if I'm having all the wide transformations, all will go to one stage only. So only one stage only will get created at that time. uh, so all the wide transformations will create it to one stage only. That's it. Okay, but within the same notebook, if I'm having narrow transformations and combination with the wide transformations like group wise, so joinings, aggregations, all these things, then I will have two stages. One stage will create, see, each job will have one stage. Okay, if I'm having one job for to read the data, there will be one stage for that. If I'm having to display the data, that will have one stage for that. Okay, each data frame will create new RDD every time by referring the old RDD. As I have told, if it gets failed, it again rebuilds by reading the tag. Okay, leave that one. But when coming to the jobs and stages, listen carefully. Each job will have number of stages. How it will get segregated? If all the similar kind of transformations will go to one stage, that is the first point you need to write. If I'm having different kinds of transformations like narrow transformations and wide transformations, all narrow will go to one stage, all wide will go to another stage. Within the stages, I'm having tasks. Tasks is associated with the number of partitions made. Okay, so tasks is associated with the number of partitions made. Means how many number of partitions I have made, that is directly proportional to the how many the number of tasks that will create. So if I'm having 200 partitions, 200 partitions will get created, 200 tasks will get created, three partitions, three tasks will get created. So those tasks only will be given to the executors and within the cores. Okay, each core will handle one partition that everyone knows. So this is what the formula that you need to understand. If you understand this one, you can easily able to identify how data is flowing from where to anywhere. Writing code is very simple, but understanding the back end things are very important to learn all these things. Okay, and you need to know one more thing, like at defaultly how many tasks, how many jobs that Spark will provide you. Okay, Spark will provide defaultly, okay, one job. Okay, for one job, one stage it will give, and for one stage, one task it will give defaultly. Okay, these are what Spark will do. Now let us understand. Now you can able to understand, going over there we can do. Okay, now see, now let me go to my DAG. Okay, let me run all because my cluster will turn off, that's why. Okay, yeah, let me go to my DAG. Now if I went to my notebook once, if I have seen this one, I have done only one transformation, that is narrow transformation. Okay, for this transformation, one job will get created for me for sure. And apart from that, I have done created, read the data here, two jobs got created for me because one for reading, one for infer schema. Dot display, one more job, three jobs got created for me. Each job has stages, as I have told, stages have tasks. And within the one more I have done. Okay, one more I have done. And after that I have done. So total, how many jobs created for me? These many jobs. 13 jobs means, see, again when you're reiterating any every time, na, it will create new RDD for you and it will keeps on doing. See this, I have reran my notebook for 3 times. So that's why every time it is creating new RDD, new job coming with the new things. That's it. If that RDD gets failed, and again it will go to the previous one. Nothing. Apart from that, nothing is there. Okay. Now let us come to jobs. First of all, this is my jobs area. If I come over here, you can see only one job is there for me. What it has done? Scan the CSV. That's it. Apart from that, nothing it has done. Okay. This is your job description. Okay. This is your job description. Okay. Now, if you click on this, you will immediately navigate to how many stages are there. Okay. You will immediately navigate to how many stages are there. Okay. See, every time 14 stages got created because every job will create with the one stage. Every job has one stage. See, these many times I have read my data like this, keep on reading my dates and all. Now every time it had read one, stage. Okay, so if just I need to view the current recently ran this one. If I click on the, if I have view this one, see, it has only one task got created for it. How many tasks got created? One task, because one partition is there for me. It got succeeded with the one task. Fine, this is a file output input area, how much it is there. Okay, if you click on this one details, you will see something called as, see, query not query execution, such equal execution, not this one, not this one, not this, not this one. Mhm. Oh, it will not be there in this, sorry. I need to click on this point. So you will get to see this one. Okay. So you need to see what is submitted, duration, or resource, so all these things and all. So you need to see what is the duration it got take. Okay, do not leave about all these max, all these values and all. Size this one, and how many this one got there. Okay, now once it is there, you need to see zero. What is the task ID for this particular? How many tasks got created? One task. What is the task ID? 13 tasks, which got created to this particular stage. Okay, it was success. Okay, who executed it? Driver node, because in the initial stage only I have told that for the free account the quota limit is very less, and you need to take the driver node, driver node and executor both are same, so that's why it had given the executor ID, which is a driver. Okay, do not think that why driver node has executed all these things, no. Okay, it has executed it. Okay, so this is what about the stages. Okay, now if you go to the stages, just let me once, I'm having one small doubt. DAG. Yeah. Want to see how many executors are there with us? You can see only one executor is there. See, active one. Okay, how many tasks it completed till now? 14 tasks. Total tasks 14. Time 34 minutes like that. Okay. Any shuffle read? No shuffle. Shuffle write? No shuffle write. Okay, only one executor is there. See, its name is driver node, active. Only this is performing all the things for me. Only one driver node, and that is also executor for me, because I am have selected single node while creating the cluster. If you have seen my previous video, you got to know what I mean to say. Okay, if you want to see the DAG, you need to go to the SQL data frame. Okay, this is what the DAG. Go with the let see, before going to that, let me first of all uh, read this, go to this job, this one, read this one. What it has done, it will just initially while reading the file, it scanned the file. Okay, it applied filter, but see, nothing applied filter. Why? Because see, I haven't applied filter yet. I have just went to the steps of jobs that I have done. I have went to where I went over here. I have opened the job of this one. This jobs I have opened. So that's why there was no filtering happened over there. Okay, there was no, this one happened. So that's why if you have seen over here, I think it will read all the files for me. Where it is there? Where it is there? Where it is there? No, 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 no. This is a predict cache unit. This one 17. This one it had read my file. Okay, I haven't given df dot display. So rows output is one. Collect limit is this one. But see, I think I need to go to the above one. I think so. Where is this one? This one. Let me go to the seventh one. Okay, which got taken. So see, it has scanned my files and decentralized to the object. Let, I think in this I need to see that one. Number of files read, one file. Number of scanned columns, one column. And because it's a only entire file I have read, and number of rows, because I have read this one, I couldn't able to see how many files are there. No, how many things are there. So it has simply decentralized to the object, that one. Okay, do not worry about all these things. These are okay, okay kind of things. Okay, now let me go to the df display. If I click on def display, now initially if you have seen some decentralized to objects, all these things and all, you couldn't able to see how many rows it had read. Okay, it just read the file. That's it. It didn't read. It had, if you have seen also, you can over there also, only one file was read over there. Output of row also one file only. See, if you come over here, if you see this one, how many files got scanned over here? See, if you have seen, number of files read one, number of scanned columns is also one. So it had taken entire into one. Okay, it was not completely. Okay, now if I go to this one, df.display, when I hit action command, you can see it had actually read, means it already read the file, it has optimized it, and it has given me, see, now it had read all the rows for me, given 1001 rows. Actually this is my actual count of my file. Okay, collect limit, nothing, see, nothing, no shufflings, nothing, so nothing happened over here. Good. Now go over here. Now just now go to filter.display. Filter.display. See, if I click on, if you click on this one, see, click on this one, see, now it had scanned 10 columns and rows output is 188 because it has filtered 188. And see, what is this filter? It has filtered to 188, but it will remove the all the null values. So Spark has some optimization of it. So every time it will do filter and it will remove null values, because if you are having null values, it is very hard to do joins, all these things and all stuff. Okay, now if I have, now if I do, now I have filtered the data. Now if I have given something called as df underscore filter dot explain. Okay, df underscore filter dot explain, and I have told every time it creates RDD, I have told now, see, these all are one RDD. Okay, again I have reran it, it created new RDD for me. Okay, these all are same thing till here to here, same thing, one RDD. Before also same thing, I have rerunning my notebook. So one more thing is there, data frames are immutable when it comes to repartitionings and all. Okay, let me explain you what happened. See, this is what my plan. If you see, initially this is my first RDD. When I have select this one, see, this is my first RDD, RDD1, which has given me my physical plan. By this, it only it will RDD will read the plan. What it will do, it will not merge with the first RDD. If you see, there is one separate RDD that got created to filter the record. So it has, what it has in filter is not null, means no, it will not maintain any null values. With that, it has done product category is equal to fashion. And as I have told, if this RDD gets failed, filter gets failed, simply it will read the above RDD, means I need to scan the files and all. Again, this will get created automatically. That is what the power of RDDs over here. Okay, so this is what about narrow transformations, how it looks. Okay, you can see only zero partition, no partitions are there. Now let me do some group by. Okay, now uh, before that, let us do some repartitionings. Okay, repartition, how many partitions are there? One partition is there for me, right? If I do df underscore filter dot what we call it as rdd dot get get a number of, let me hide this one, I want this, let me hide this for some time. Okay, okay, let me run it. One partition is there. I told now we can do repartitioning. Now I'll do repartitioning. Okay, now what I'll do df underscore repart, I take something repart. Okay, I will take df underscore filter, which is above one, which is having one partitioning, dot repartitioning to 2. So now I'm taking r two repartitions of two partitions I'm taking. Okay. If I have ran it, executed successfully now. If I have ran this again, so this is df underscore filter, which is already having that partition. This is a old one. I told now every time it creates new RDD for me. This data frame is already there because it needs to preserve for one RDD. If the after this one fails, it need to read that one. So what I need to do? See, simply I need to do df underscore repart dot rdd dot get number of partitions. If I perform this one, see, I'll get two partitions. So now my RDD repart has two partitions. I can use these two partitions to perform any other narrow transformations or anything. Okay. But it will take only one partition only for me. Okay. For suppose, if I have done some filtering, okay, in this again, in this filtering, okay, what I will do, okay, first of all, let me do df repart dot display. Okay. After that, I will do df underscore repart dot display. df underscore repart dot display. So I have got the entire result now. So let me first of all, within this I want to just filter only sunglasses, product name sunglasses. Within faction I got I want only sunglasses. What I need to do, df dot filter, okay, column of, okay, uh sun, not sunglasses, product underscore name equal to sunglasses. That's it. Sunglasses. Okay. If I have done why paraducta. Wow, super product. Run as suggested. Accept and run. It had created, okay, small spelling mistakes. I was weak in spellings. That's fine. df underscore repart dot display. If I do repart dot display, now let us view the DAG, what it will do. Okay. Now again, this has two partitions. Let me go to my jobs. Okay, two jobs got created for me. One stages were skipped. Okay, you will get to know why it skipped. See, what it has done means simply, see, you can see something called as exchange over here. Exchange means something, nothing but it is a shuffling. Okay. It think nothing but shuffling. Exchange is a shuffling. In the above stage 18 narrow transformation, we have seen that we have just filtered as per the fashion. As per the fashion. If you have seen this one, I have just filtered as per the fashion only. See, above, filtered as per fashion only. All the product categories fashion. But again I'm doing product category is equal to sunglasses. I told now, whenever I have added some extra, see, this thing I can add in a single data frame only. But again I have came again and added this one. But Spark will not do anything with my things that I have wrote. It will do back end processing and all. What it has done in the DAG, simply told, boss, you have done everything fine. This is something I call it as a read exchange. Okay, what this will do, it has, boss, this everything is there, whatever the data I'm having. Okay, already you have done with fashion only. Within the fashion only you want to do further filtering and all with some sneakers or anything. You don't do anything. Again create, again scanning the file, again doing all these things, these are waste. You do one thing, whatever the data I'm having, I will give you, one stage will get created, stage 19, and that will be exchanged to this one. This is what read shuffle. This is what I'm reading shuffle. This stage 19 is reading from this shuffle. Exchange means shuffling, means giving, means providing the data to partitions. That's it. Apart from that, nothing. Okay. Now, what it is doing, it is writing in stage 19 for me. Okay. It is writing in stage 19 for me. See, if you see shuffled row RDD over here, something. Okay. If I go to my jobs, if I go to my jobs, one job got created for me over here. And if I go to my stages, see, stages. How many stages got created? One stages, because both are narrow transformations only. If both are what we call it as this, what we can say, wide transformations, it will not bear. Okay, both are narrow transformations only. And apart from that, what it had done, let me go to my executors. Let me click this one. It had first scan my things. See what it had done. Sorry. Yeah, see, number of files read 1. Number of partitioned columns is also 0, because see, it will not give to two partitions. Okay, it partitions are there, two are there with us, but it will only give to the first partition. Total 188 records it had read. Okay. Within within that 188 records, it had done some filtering. Means what? Nothing. It will do non-null. It will remove all the null values for me. And now it will exchange whenever you're watching exchange, means it is shuffling happening between the partitions. Okay, now it will do shuffling between the partitions, because I have taken two partitions over here. Where before, see, I have do repartitioning over here. Now it will perform two partitioning. See, now you can see how many partitions it got there also. See, number of partitions are 2, and records read 188 records were read over there. Okay. Shuffle partitioning type 3. Okay. Shuffle partitioning type 3. Okay. Now come up after performing entire partitioning and all. See, you can see simply, you can see exchange round partitioning, two partitions are there, so which I have done repartitioning as per this one. Finally it will collect the data. Finally it will collect the limit of everything. Okay, that's it. This is what happens when we perform. We need to, if you want to view the DAG correctly, this is how you need to view the DAG. Okay. Now let us leave this one and let me go to the wide transformations. Okay. This is very much fun. Okay. This is wide transformations. Okay. Wide transformations. Let me take this one. What wide transformations means? I need to perform somewhat of some group by now. See, I won't do anything. I'm not applying this on this repart or anything. Okay, let me apply on df not underscore filter also. Let me apply on the first data frame, which is df. Okay, df. I'm not touching any data frame which I have done on this particular narrow transformations and all. I want to perform on this only this particular df, which I have read in the initial stage. Okay, or if you want, I can take one more new notebook also. New notebook also. Or no. Let us not take any new notebooks and all. Okay. Let me keep it like that only. Okay. Let me keep it like that only. Now what I will do, let me read the data. Okay. What I will do, first of all, let us perform only the y transformations. Okay. Before that, what I need to do, df underscore wide. I'm creating one new data frame. Within that, I am doing df dot. This is my first data frame which I have read. Okay, df dot. Let me do group by. See, with respect to product category and not pivot and all. Let me do group by with respect to product category. Okay. uh, and after this one I have once I have done not product category na, yeah, product category, and I want to do some what I need, what we will do, let me count let me count the order IDs which have perform, which means as per the product category I want to count the order IDs. Okay, dot what I'll do, aggregate agg, and what I'll do, column of, before that I want to give count, count of order id, or order idea, product idea. Okay, let us take product id, each product have one product id. Okay, how many products are there in that particular fashion. Okay, I want to view this. Okay, let me run this one. This is correct only, I think so. Yeah. Now, see, now if I have given df underscore wide dot get, what is this one? Not get, what I dd dot get number of partitions. Okay, see, this is a wide transformation. Defaultly, you will see 200 partitions which got created for it. Okay, defaultly, it had created 200 partitions for it. Okay, now let me do df underscore y dot display. Now let me run this one to view the DAG. I want to view the DAG. That's why. So if I have viewed this DAG, okay, if I have seen this DAG, you can see that how many, what is the count of product. Kitchen I'm having 203, fashion one, this one I'm having this null 0, all these things. Let me go to Spark jobs. See, there are so many Spark jobs got created, but almost all 19, 20, 21, 22, all these jobs were skipped, which means not performed. Okay, now let me go to the job 18. Now if I go to this job 18, same here also you can see shuffling over here. Okay, before going to the jobs, you can see completed 2 stages. What are those 2 stages? What are those 2 stages? So both are wide only, 20 to 23 only. Okay, but see over here, same. In the stage 22, it has scanned the CSV and it has went over here, read shuffle, and it has wrote everything into the right shuffle, and from there it had went to this particular whole stage of code gen code. Okay, now once this was being done, you need to navigate to the stages page. Okay, if you are there in this page, okay, there are some stages you are watching over here. Okay, but some stages were skipped. Where are those stages? Some stages were skipped. Okay, some stages were skipped out of some, what we call as, what stages got skipped over here. Job 21, 22, and all these stages and all. Let me go to what is the skipped stage, this one, job. Okay, see, this was skipped. Why this was skipped means, see, this is a job 25. It was succeeded, but this was skipped actually. Skipped stages. 24. This is also skipped. Why? Because there are 200 transformations, not transformations, 200 partitions are there. So 200 partitions, it will take only one partition only for that entire data to read. See, data read shuffle also very less it had happened. It will give only one partition only for that. Okay, it will give only one partition only for that. Okay, what are the remaining stages have, which are empty partitions? Because as I told, how many white transformations are there within all the stages, there are so many tasks got created, so many tasks were skipped. Why? Because all are empty partitions. Spark will say what I need to do with those empty partitions and all. Simply it will skip those things. You can see the, I think the 25th, this one, yeah. See, if I have ran this one, see, unordered, nothing. You can see something called as unordered over here. Okay. And duration also, I can see there is something is there, man, to check. Where is this one? Not this, not this. Yeah, yeah. See. Yeah, yeah. This one, this one. See, this content consists of jobs of 18, 19, 20, 21, and 22. These are the job IDs which I have given for this entire thing. If I have gone over here, see, it had skipped all the jobs, okay, and it had given me job 18 only directly, where it has 2 by 2 stages which got succeeded. Why 2 by 2 stages? It had given one stage is for the first job which got read, second stage is for the narrow transformations which had happened. Okay, so these are what why stages got skipped over here. That's it. I hope you understood on this particular part. And now let us navigate toward this one. Okay, this is what group I have done. Now now I want to filter only kitchen. Okay, here I am performing one more what we call it as filter transformation. Okay, what I will do, I will write over here df underscore filter underscore 1, okay, equal to df underscore wide dot filter, okay, where column of this yeah, count underscore product id. This should be column of count underscore product id. This should be greater than, let us take one value, greater than 2 not this one now, 188, greater than 200. Let me take 200 so that I'll get only kitchen and as well as electronics. Okay, let me take 200. 200. Okay, let me run this one, or let me run all my notebooks, entire notebooks. Okay, now see, new jobs means new entities got created. Okay, now let me do not df underscore white dot display, df underscore filter underscore 1 dot display. Okay, now because I want to see only those rows only, let me run all again, please. Now some jobs got created. 41 to 44 jobs got skipped. Why? Because these are all empty partitions. Why? Because defaultly we will get what we call it as because this is a white transformation, so you will get total 200 partitions by default. It will take only one partition. That partition is this one. Rest of all the partitions, if you combine all the partitions, you will get the total score of 199 like that. Okay, if I view go to job 40, if I go to job 40, let me go to jobs, let me go to jobs. See, if you go to jobs, there are total, see, if you go to jobs, if you see job 40 only got succeeded. Okay, job 41 to 44 got skipped, right? See, if you go 41 to 44 jobs, all these are skipped. Okay, why? Because these all are empty, what we call it as empty partitions and all. Okay, if you have seen only 40 only got succeeded. Okay, but if you for suppose if you calculate this 100 by 100 skipped, because These are 100 partitions are there, 100 by 100 skipped. 100 plus 75, 175, plus 20, 195, plus 4, 199. So how many partitions got skipped? Total 199 partitions got skipped because those all are empty partitions. This is what happens in the Y transformations. It will defaultly give 200 partitions for you, but while executing, it will only take how many partitions are required for that particular file size and all, and rest of all the jobs which consist of partitions will get skipped. Okay, this is what happened. If you do addition of all these things, you will get total 199 partitions got skipped, and only this job has run. If you have run this, if you have clicked this one, you will navigate to the stages. This is what the this one. So there are two stages are there, stage 58 and stage 59. Same, read the CSV, old stage code gen, exchange happened, and here it had done because it optimized it. That's it. Okay. Now, if you see this one, it has two stages now. The first stage is 59, sorry, 58 having this one. You can see what were the tasks that got executed from this. Okay, this here one task got executed within the this one. You can see what are the tasks got executed. And if you want to see what are the tasks that got executed, simply go to the SQL storage data frame and just click on the latest query plan. Here you can see something new, which whatever the aggregates we have discussed in our theory class, all those things you can visualize it over here. There is something called as scan CSV. Everyone know this one. It will scan the file for me, read one file, see number of partition columns are 0, scanned columns are 2, like that it is there like this. Okay, how many rows are output are there? Initially I'm having 1001 output, everything is there fine. So initially scan. What it has done immediately, hash aggregate. I told na, hash aggregate, it is a SQL tool. Okay, not SQL tool, what we can say, this is a tool that we use over here. Means they are the binary bytes. So what hash aggregate will do initially, it will helps to aggregate the entire whatever the group bys or whatever the rows we are having. It tries to grouping up and aggregate this one. Okay, it is generally used in Spark, Kafka, and all other tools and all. Okay, once it aggregated, okay, hash aggregate, what it has done, it has done product category. Okay, product category, it has done first of all done that one. Hash props key as per key, the value is 1. Okay, how many rows I have got after performing aggregate? 6 rows. Okay, now once I have it was done with some basic aggregate and all, then immediately exchange happened. Exchange means what? Distributing between the partitions or nothing but this is shuffling. Okay, now how many blocks it had read? 6. How many partitions are there? 200. Records read are 6. For 6 records, 200 partitions are enough. Huh? One partitioning is enough. That's it. Shuffle records written. Any shuffle records are written? Huh? Yes. Shuffle records are written to another stage and also that is 6. 6 records are there. Totally I have got. Those were written. Then again what happened? Then again you can see something called as hash aggregate for. Why you are watching this? There are some keys are there. Again they have done sorting and rows output is 6. Again it had came, and finally it had performed the filtering. I got rows, 2 rows, because this is a narrow transformation I have done. Okay, this one it had taken over here, collect the limits. So it has collected all the limits for me. Okay, now here it will perform the aggregation for you. Okay, here it will first of all, I told now it will first of all view what will happen. Six rows are there. how many shufflings happened? All 6 rows got shuffled. Okay, how many hash aggregates have done? Output is 6 rows only. Yeah, as per the sort. Finally, I have done arrow transformation. Two is an output, and this is what collect came over here. So these are the major concepts that you need to understand in this particular video. Okay, there is one more last video is there that will come tomorrow. Okay, please watch this video because already it had taken 2 hours 37 minutes, so it will be a big video because I need to send this video to it will take some time. So tomorrow I'll cover tomorrow I'll send immediately tomorrow I'll send video for you. Okay, on that video you can view what are joins, what are Spark SQL engine techniques, what how we'll store the data, and we have told something called as catalyst optimizer, how it will optimize the data, how it will optimize the logical plans and all and convert it to physical plans and all those things. With respect to that, there is one more last topics are there, which is Spark optimization techniques. Means what are the optimization techniques that are available, like broadcasting of broadcastings, and as well as persisting, salting, and as well as partition prunings and all. So all these things we are going to discuss in the next video. Next video is very short video. Okay, it almost covered 2 hours. If you have completed these 3 videos of 2 to 6 hours video, so I think you are able to understand Apache Spark and you are fine with to go with the PySpark coding. Okay, so next once this Apache Spark completes, we'll go with the PySpark coding. Okay, that's it. Thank you.